I think we're just going to get started. We got a lot of content to cover today and a lot of mouths that need to get some words said. So thank you, first of all, for attending. In case you couldn't read, you're in the session to talk about NSX load balancing. So my name is Luke Hoffer. I'm a systems engineer with the Networking and Security business unit here at VMware, which obviously means that my primary focus is NSX. As part of that function, I also lead an internal team that focuses on load balancing functionality specifically within NSX. With me today, we've got Rush Munir. He's a senior product manager with VMware, responsible for NSX, obviously, and the load balancing functionality within NSX, amongst other things. And then we've also got, for our grand finale, Mr. Luke Sipple. He's the IT engineering manager for Self-Esteem Brands. You might know them better under their subsidiary's name of Anytime Fitness. Has been an NSX customer for a while, and at the end here, obviously, we'll be running through their journey to adopting NSX, and obviously specifically the load balancing functionality. So just high-level overview of the agenda today. We'll cover the disclaimer first, obviously, so that we don't get sued. I'm sure you've all had time to read that. We're going to start with just kind of an overview of just general load balancing concepts, market in general. Rush is going to cover that. And then once we've done that, the intention here is that we're going to run through the three main use case areas that we talked about in the title of this slide. So we're going to talk about using load balancing for scalability, availability/reliability, and security. And specifically, touch on what those concepts are and also how we do that within NSX. So I'll be covering that piece, and then at the end, we'll bring Luke up to talk about Anytime Fitness's journey to adopting NSX. So with that, I'm going to turn it over to Rush for the initial overview.
Can you guys hear me clearly? Good. Okay. Okay. Before I start, I want everyone to stand up. I just want you guys to stand up, stretch yourself. Yeah, stretch it. Yeah. Perfect. You guys can have a seat. Thank you, guys. So my name is Rush Munir. I'm the product manager for NSX Load Balancer. It's a funny picture. When I was creating the slide, I was just thinking, what are the IT challenges which today most of you guys see it? Okay, before I go into the slide, how many of you guys, raise your hand, how many of you guys know about the ADC? What's ADC? Do you guys know about ADC? Okay. How many of you guys know about the load balancer? Are you guys using it? Raise your hand. Perfect. So apparently the ADC is a new name. What I can say is for the load balancer. Load balancer is one of the portfolio within the ADC. It's called Application Delivery Controller. So there are different components in the ADC. For example, load balancer is one of them. SSL offload is another. Web application firewall, or templatizing, or customized scripting are the different portfolios within the ADC. So what we are going to talk about today is about NSX load balancer. But within the NSX load balancer, we have different components like SSL offload, customized scripting, and eventually other security features. So what are the top IT challenges which I've been talking to many customers, and you guys can always tell me. And what I hear from the customer is that these are my top challenges. I want my availability of my application. So I want my application to be running 24/7. I want that scalable application. Rather than having one single load balancer doing the tens and millions of connections, I want that horizontal scaling for my application. I want to scale my application. I want to do the auto scale of my application. And then lastly, I want the security of my application. And this has been the common IT challenges which we are seeing it across all of our customers. Moment I talk to the customer has this issue. And that's what we want to talk about today, how NSX load balancer helps with some of the components. What's driving the factor, and why we are seeing these challenges, right? And what's the motivation, and how we can fix it? The customer which I talk, they want to automate their environment. They want to have that single button which can completely automate their orchestration, application, and load balancer. Hey, I want to turn on my load balancer, just single button, deploy with all my configuration. I want to deploy my application with VRA, VRO, or any orchestration layer on the top. I want to do it. I want to automate it very fast. I just don't want few days to deploy it, my hardware appliance, and it takes maybe 2 weeks, 3 weeks to enable that load balancer application. The second thing which we have seen is time to reaction, which I was talking about. Rather than taking 2-3 weeks to deploy my application, I want to deploy in 2-3 hours. How can I deploy it very fast? How can I enable my IT team or networking team or application team to enable it very fast? And the last thing is what my CIO cares about is CapEx saving. Hey, I don't want to spend tons and tons of money for any hardware appliances or for the load balancer. What I want is, I want the scalable solution which can do the horizontal scaling for me, but I don't want to spend X amount of dollars. And the load balancer is a very expensive product. So those are the things which we are seeing in the today IT world. So talking about the load balancer. So the first load balancer came in 1996. Just to guess my age, I was 11 years old. You guys want to guess my age? How much I was today? What's my age? I was 11 years old in 1996. Anyone? I consider myself as always 21, although it's 31, but that's correct. There are different evolution of the load balancer which we have seen across it, right? Initially, it started with the OS-based load balancer. Then we had that physical giant hardware boxes, which a lot of customers still use it for the high scaling end application. We also seen the virtual appliances. And in 2013, we introduced server load balancing, which is part of an NSX platform. How many of you guys know about the NSX load balancer? NSX has a load balancer. OK, let me ask this question. How many of you guys have NSX in your environment? Can you guys raise your hand? Wow. Great. And how many of you guys know about NSX as a load balancer, or you guys are using it? Perfect. Thank you, guys. So in 2013, we invested in the load balancer, and we are continuously planning to invest more and more into the terms of a load balancer, and you would see in future slides. Just to give you a high-level overview, what is server load balancing? And just to take you into the slides, I'm going to do next. Very simple. I have my application. I want the availability of my application, scalability of my application, security of my application. Rather than I can have a multiple server, I want to just simply load balance it. So server load balancing sits in the front of your web application or your standard application, Microsoft Exchange, SharePoint, doesn't matter. It does the load balancing for all your web or internal application, right? Whether it's a mobile client or whether it's a desktop, whether a user is trying to access something. It can do the very, very good load balancing. So we say as a server load balancing as a part of an NSX platform. So what are the typical deployment which we are seeing with more and more customer? And this is what we have been seeing it, how the adoption of the load balancing is changing. If you go back trend before 5 years, 10 years, there was a physical hardware load balancer, single load balancer, again doing tens and millions of connection. What are the challenges with that approach? It scales very good. Absolutely no doubt about it. But my challenge is I have a single point of failure. My challenge is if I want to enable my application team to be very faster, I want to have per app based load balancer. I want to completely segregate my environment. I cannot do with that model. Rather than doing the vertical scaling, what we are seeing with DevOps and app-centric model is we are seeing that horizontal scaling where I want to have per app based load balancer or per group based load balancer. What it allows you to do is, if I want to do any changes to my application, it doesn't affect rest of the other application because it's completely isolated, completely segregated from the rest of the environment. So what are we seeing it in the terms of what our customer adopting is, our customer are adopting per application or per environment load balancer versus per environment load balancer. So they are dividing into the silos into the group or per application. We are also seeing the scale-out model as a more horizontal rather than the vertical. Low cost. One of the things which talking with many customers and what we are seeing it over and over again is, hey, I'm spending $10 million in the load balancer, I don't want to spend it. The CapEx is too high. I want the low-cost base load balancer. I want that ops intelligence into the load balancer where I can see my analytics visibility. I want to see what's my throughput, what's my WIF status, or I want to see in overall how my application is doing it. If I have any error in the application, what's the reason behind it? I want that analytic engine within the load balancer. And the last thing is I want to automate my environment. Hey, I have that template for the SharePoint. Rather than deploying that 10 times or configuring that 10 times, I just want the single template which I can push the button, and it can automatically configure and deploy within the different environment. So I want to completely automate and orchestrate my load balancer. So what does the NSX load balancer do? And we do have some plans to expand it, and we are continuously investing on the load balancer. As of today, we can do very good high-speed layer 4 load balancer. We can also do the layer 7 load balancer, HTTP and HTTPS. So SSL offload is one of the things which we do within the NSX load balancer. We can do the L7 manipulation. If you want to have any L7 rules, we can have it as a part of an NSX load balancer. We do have a TCP multiplexing support, if you guys are using the TCP multiplexing. Also, inbuilt programming support. So if you want to have that customized scripting within the product, we do support it, something called app rules. So application rules allow you to do the inbuilt programming support within the NSX load balancer. So there might be some feature not available within the product. You can use within the application rule to support it. We also have an integration with the VRA and OpenStack. You guys are aware of VRA? Familiar with it? It's an orchestration tool, VRA and VRO. It allows you to orchestrate your environment. So we do have an integration with OpenStack and VRA. And lastly, we also have an integration with the third-party load balancer. So today we have an integration with F5 and RV networks. So if I'm a customer and I don't want to have a two different environment, I just want to have single pane of glass for managing all my load balancer infrastructure, you can absolutely do with the NSX Manager. So I'm just going to give you guys how many customers are using it and how much serious which we are in the business of the load balancer. So we have today 160 plus customers deployed in production for the NSX load balancer. So people are actually using it, and it's pretty real. We have a big financial customer who has more than 700 NSX load balancer, with big healthcare who has deployed 200 NSX load balancer. So deployment is going into the higher level. More and more customers are starting to adopt it in the terms of an NSX load balancer. So these are some of the name of the customer which has been using it. Some pretty good brand name over here, from the healthcare industry to the financial banking, some service provider. So why customers are deploying the NSX load balancer? And these are some of the use cases which we have figured it out over the time. These are the reason. The number one reason, it's a simple licensing model. We don't license on the base of the throughput. If you buy NSX, you guys know how NSX is licensed, is based on the socket. We license on the same thing. If you have NSX, you get the load balancer for free. You don't need to pay any extra penny for that. We allow you to do the better capacity planning. So if you want today, let's say there are different instances of the NSX load balancer. It comes with the compact, large, extra large. You can start with the compact, and you can see that, hey, my traffic is going about X amount. You can always go easily into the large. It's very easy. With one single click, you can upgrade it from compact to large. No need to worry about it deploying the different hardwares. Automation, it's fully automated. It's an API-based load balancer. You can use your external third-party orchestration tool, maybe Puppet, maybe Chef, maybe VRA, VRO, you can absolutely use with the NSX load balancer. Speed up of delivery, it's just very fast to deploy. If you have already NSX, you just don't need to worry about it. You just click the button, do few click, 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 and you are able to enable and start using the NSX load balancer. It's part of an NSX platform. It's just within the platform, just makes easy that I don't need to have an additional device to manage it. It's just part of a platform. And lastly, it's a reducing CapEx cost. We have seen customers spending tens and millions of dollars. Now they are not spending that amount of dollars with the load balancer because NSX is able to do good amount of job what they are looking for in the terms of end use cases. So what's vision? We have similar vision what NSX has it. We want to have an NSX load balancer everywhere. So when I say everywhere, it's literally whether it's your public cloud infrastructure, running on the Amazon or running on the Azure, or whether it's integration with the containers platform or within the microservices. We have few customers today running NSX load balancer in their microservices environment. Whether it's an on-prem private data center, whether it's a service provider model, or whether it's an Internet of the Things, we want to have an NSX load balancer everywhere. That's our vision. That's what we are working on in the terms of bringing the right solution to you guys and providing the right load balancing solution. Again, the story remains same. Horizon View, great use case with the NSX load balancer. If you guys are using Horizon View, we have a pretty good white paper which says how you can load balance your Horizon View VDI environment with NSX load balancer. Same concept, availability, scalability, security, that's what we are working in the terms of bringing the right features in the NSX load balancer. So I'm going to shut my mouth over here. I'm going to pass on to Luke, who's going to go into more technical details and give you more information about the NSX load balancer.
All right, thank you, Rush. So like Rush talked about, we've kind of established what the landscape looks like in load balancing today and some of the core tenets of what we're trying to accomplish with load balancing. So now we're going to talk a little bit more about what that looks like when we actually do these things in NSX. So foundationally, obviously, as you can see from the slide here, the load balancing functionality that we're talking about is based on the edge service gateway. So this is obviously the same edge services gateway within NSX that we use for other things like terminating VPN tunnels, NAT, peering with the rest of our outside network. And as Rush mentioned, it's available in these different form factors. And you can see from this, basically the X large form factor is going to be the only one that really makes a difference to us versus the others. That's what we recommend for load balancing deployments where you get away with it. You'll notice what we don't show on these published numbers are things like connections per second and throughput, just because that can vary so greatly depending on the workload and how you're deploying this. But obviously, as you might imagine, that X large form factor is going to get you the best performance. Not to say that there's anything wrong with the others. The compact is fine for a lab environment. And like Rush mentioned, that's something that, as you grow your environment, that's something that can be redeployed in the different form factors as well. But really what we accomplish here is a few different things. And this is really how we enable some of that benefit that Rush mentioned in the sense that, from a cost perspective, for example, because we don't charge anything for an edge services gateway, and as such, don't charge anything for the load balancer, we're not beholden anymore to creating this big monolithic appliance at the edge of the network that we use to scale everything up with. We can deploy as many instances of this as we want to be able to use that scale out topology and also reduce our single points of failure in the network in that sense. And then consequently, obviously, as we all know, this is integrated with NSX. So that's something that I get the same benefits that I get around other functions that NSX deploys, around abstracting functionality from the physical infrastructure so that when I deploy a load balancer, I do that the exact same way on-prem or in any of the other stuff that Russ had in the previous slide. So if I'm moving to a different data center with a different physical infrastructure or a public cloud provider, I'm going to deploy these services and consume them in the same way. Similarly, I can consume the load balancing functionality here through the same API that I consume all my other NSX services around. So I can minimize the number of integration points that I've got when I move to some sort of automation or private cloud framework as well. So when we actually deploy the edge services gateway as a load balancer, there are a couple of different ways that we can do that. So the first and potentially simplest is the inline deployment topology. Or I also, in parentheses here, put transparent, because when you're actually configuring this topology in NSX, when you're creating your server pool, there's a checkbox that says transparent, which for me initially wasn't necessarily obvious, but that's how we accomplish this inline deployment topology. And when we do that, that tells our load balancer that we want to have this model where the load balancer is going to be sitting in the layer 3 path of the traffic between my client and my servers. And that, as such, is going to require that when we get a request to our virtual server address or our VIP, depending which nomenclature you're comfortable with, What we're going to do is when we receive that request, we're going to do a destination NAT on that so that we change that destination address from the VIP on the load balancer to one of the virtual servers that's sitting behind me. And when we do that, then the server, obviously, is going to receive that request, and then it gets its return traffic. We un-NAT it, if you will, and send it back to the client. So some advantages to deploying this way are that when we do this, the servers receiving the request see the original source address of the client making that request. So depending on your application and what you're doing around analytics, that might be important to you for a deployment. Some disadvantages of doing this, and some of the reasons that we might do the next option are that as we're sitting in the layer 3 path, because when the server sends its return traffic back to the client, it's sending it to the actual client address. In order to make this work and make that traffic go back to the load balancer has to be your default gateway in this sense. We have to be inside that layer 3 path natively because the server's not smart enough to know that it needs to send it somewhere else, realistically. As such, then, that edge services gateway that we deploy for the load balancer is my default gateway, and from that we can intuit that we are not using things like the DLR and some of the other functionalities that we use to enhance some of the routing that we do in NSX. So, our alternative is the one-armed or proxy deployment. The one-armed is if you don't check that transparent box, what you're going to get. I just put proxy in there just because that's more of a naming convention. There isn't really anything that you're doing in NSX to specifically configure this other than not checking the box. But this one works a little bit differently. So this one we get away from that requirement to have the load balancer actually sitting in the layer 3 path of my traffic. So when I actually get the request from my client, in this case, they're obviously still sending their traffic to the VIP or the virtual server address that I've got associated with the load balancer. But now I need to do something a little bit different here when I'm the load balancer. So not only do I have to change that destination address and perform that destination NAT on that traffic, I also now need to change the source address. So I'm going to change that source address from the client's address to the virtual server address that I've got on my load balancer. The reason that I'm doing that is so that when the server that ultimately gets that request needs to send its traffic back to the client, it's going to send it back to the load balancer instead of trying to send it directly to the client. That's how we get around that requirement for being in the layer 3 traffic path. So that has some implications, obviously, because now my servers that are receiving that request don't see the actual source IP address of that traffic. So again, we go back to that potential requirement for either doing analytics based on the source IP that I'm getting that traffic from, or any number of application requirements that might be interested in seeing that source IP address. And there's the potential for issues there. Now, in a lot of cases with more modern applications, we've got the ability on the NSX load balancer to insert an HTTP header called xforwarded4, where basically we just add an HTTP header that tells you this is the IP address that I sent this for. And a lot of times we're able to get around it that way. That may or may not be an option. But that's typically how we would get around that if we need to do that, either application dependency or X. But as an advantage to doing this, obviously now we can use things like the DLR as the default gateway for my virtual machines, so I can take advantage of that distributed routing that I can do anywhere else in NSX. And I also don't have to re-architect any of the other routing or anything in my network, because now, basically I've just got this load balancer, typically that's just going to be sitting on the same subnet as my virtual machines, so I can just plop it right alongside whatever workloads I'm going to be distributing out load to in this case and not worry about it, just because obviously, because it's changing that source address before it sends it to the server will automatically know how to get back to it regardless of what its default gateway is. So that we'll jump into the first use case, and this one is obviously the kind of the core use case or the original use case for load balancing. So this is for scalability. So obviously the problem that we had and do have is that for any number of applications that are out there, a single virtual machine or physical server, whatever you're using in your environment, might not be able to handle the load that all of your clients are going to throw at it. So obviously the ultimate intention is that we'll want to have a way to distribute that out amongst multiple servers, right? Pretty straightforward stuff, and obviously something that is something that we would always expect of a load balancer. Of course do this, and there's a little bit of nuance around that. So when we're actually configuring our server pools, one of the things that we do as part of that step, in addition to choosing the things that we're going to actually distribute load to, And obviously the same advantages that we see in some of the things like the distributed firewall and NSX and through our integration with vCenter apply here too, whereby we're not only able to just say send it to these IP addresses, but we can do things like choose a virtual machine or use a security group. So use some of that other intelligent grouping that we would use to say that if you've got a VM name like this, or if you've got this security tag, we can group virtual machines that way. But in addition to choosing the actual servers that we want to distribute load to in order to provide the scalability, we're going to select how we want to actually distribute the traffic amongst that load. And that can be anything from as simple as a round robin, where we basically just sort of do 1, 2, 3, 1, 2, 3. Every new request I just send to the next server, regardless of what I've sent to them and what they've still got active. We can use the least connections option, where I can intelligently look and say that these two servers have 2 connections each, but the middle server only has 1, so I'm going to send it to the middle server, so I can basically evenly distribute that load to make sure that I can get pretty close to where my workloads should be as far as evening it out across the different members of that pool. Or I can use these different parameters at the bottom and just create a hash off of either the IP address or part of the URL or URI to get that file path, or even something in the HTTP header. Create a hash based off of any of those parameters to choose which server I'm going to route that traffic to. So once I've done that, the next thing that I need to worry is this concept of session persistence. And the idea here, the old example that we use typically is around the online e-commerce example of a shopping cart. So if I've got something stateful on that server that is maintaining state for a client session, I obviously want to make sure that that client always goes to that server, right? So in the e-commerce example, if I've got something in my shopping cart and I go to a new page on that site, I still want that to be in my shopping cart, right? So when we do that, there are a few different ways that we can achieve that as well. So when we create an application profile for our server, this is one of the major things that we're creating there. So as you configure this load balancer, one of the options that you're going to have on here is going to be this persistence. You don't have to set any kind of persistence. I mean, if you've got a completely stateless application and you've done all the agile 12-factor stuff to your app where you don't care what server you land on, that's fine. We don't have to do any persistence. We can just spray traffic all over the place willy-nilly and not care. But if I have an application that is maintaining some sort of state in that sense, then I can choose either to just do a simple, based on the source IP of the traffic. So obviously the load balancer sees this, so don't worry about any of the stuff we talked about before with the deployment options. But I can just say that every time I receive a request from this specific source IP, I want to send it to server B, and just leave it at that. If we want to get a little bit more complex and make it session-based, where potentially I would have multiple sessions from the same client, for example, or any other kind of example like that, I can actually do this persistence based on cookies that I either insert. So when I insert a cookie, basically the load balancer is just going to add a new cookie to that client session. And then when it sees, obviously, traffic where that cookie is set again, it knows that that's part of that session, so I need to send it to that same server. I can prefix it onto an existing cookie, and that's typically going to be a pretty rare scenario, but where I'm using a client that might not support multiple cookies in that session. All of the major browsers today support multiple cookies, so again, that's not typically going to be an issue. Or I can even look at the session ID. If I tell my load balancer to look for a specific string in that URL that's going to constitute a session ID, then I can actually make that session persistence based off of that as well. So that's it for the easy part as far as scalability. So the next one is availability. And realistically, this kind of ties in to what we talked about before. So I obviously, when I'm distributing my traffic against multiple servers, I've already really added to my availability because I've reduced that one VM or one physical server as a point or a single point of failure, right? And it's obviously better if I've got 3 servers and one goes down. I can still serve up 2/3 of the requests, right? But obviously, we want all of our requests to work, right? So this application monitoring and availability functionality is what we use to be able to say that if a server is down and it's not able to serve requests, and that can obviously mean a few different things that we'll look at, but I obviously want to be aware of that and not quest to it anymore. So in order to do that, when we create a server pool in NSX, one of the things that we can assign there or a virtual server in NSX, well, one of the things that we can assign there is a service monitor. And we can actually create these ourselves in the user interface. And there's different ways that we can do that. So it can be very rudimentary. So starting from the top, the ICMP option here is basically just going to have our load balancer pinging each server in the pool and seeing if they respond to a ping. That's obviously pretty rudimentary in the sense that all we're really verifying there is that that server is still there and its network stack is still up to some extent, right? Better than nothing, obviously, and for a lot of applications, that might be all that they're capable of responding to a load balancer with. So we can at least see whether a server is down in that sense, or for whatever reason, not able to talk on the network. Next step up and a little bit better is the TCP/UDP option. Basically what we're doing there is just trying to open a socket on each of the servers in the pool, so that if I've got web servers, I'm just going to try to open a TCP connection on port 80 and see if it actually succeeds. And I can get a little more granular than that, so I can send TCP extensions and stuff like that and look for that when I'm opening that session. So I can make sure, do some stuff beyond just the network stack in that sense. And then today we've also got the HTTP or HTTPS health check or service monitor that we can do there. And that's going to take it a step further. So when I set that, out of the box, I can just do it and point at whatever server I've got, and it's just going to send an HTTP GET to that server. And as long as it gets a 200 OK response back, it's going to say that server is still alive. So when I do that, obviously, there's some other stuff and other parameters that I can put around that, so I can look for a specific URI, to go to a specific path server, obviously, if there's a specific page that I want to monitor for and that kind of stuff. But basically, we're creating an actual synthetic transaction in that sense against this web server, so that we can not only verify that, yes, the server is still alive, the network stack is still up, but we can also verify that my IIS or my Apache instance is still up and running and still responding to requests in an appropriate way. So the last thing, and this is where we get into some of the more complex intricacies, and it's not necessarily specific to security, but Rush mentioned before this concept of application rules. Obviously vendors call these different things. So you might call them, layer 7 rules or I rules or whatever the nomenclature that you're inheriting from a previous vendor is going to be. But that's what a lot of our security functionality, not all, but that is based off of. But really the concept, when we talk about security in the context of a load balancer, in my anyways, obviously there's a lot of stuff we could do if we wanted to, but in my opinion what we should really be after here is using the load balancer to stop stuff that's going to get through the firewall. For those that haven't heard, NSX already has a pretty talented firewall. So I can already do stuff like control what ports and addresses can talk to each other in the network without a load balancer. And that's obviously a place that's going to make more sense to do that. So really what we're after here is stuff that would make it through that and be able to, at an application layer, take some actions on that. So that's going to be, some of the denial of service attacks, like I mentioned, slow LoRa, some brute force attacks and that kind of stuff on here. Even just some of the reconnaissance that we can do through stuff that we expose to the web. We'll talk about server masking as an example, one of the things that we'll do in here. And then obviously there's some of the more hygiene-oriented, the SSL offload that I mentioned there, where maybe my servers, either I don't want to put the load on them to do TLS, or perhaps they are incapable at an application layer of doing TLS. By using that SSL offload, I can actually have that traffic secured when I send it out across the internet, out to that big scary world out there, but then still not have to be able to support that on my actual application server sitting behind the load balancer. So we'll start with that one first. Really, it's pretty straightforward. The first thing that we do, or kind of one of the fundamental tenets of having an SSL or TLS offload, obviously, is going to be that we're going to need a certificate for us to be able to handle this authentication handshake with. So the first step is going to be to install a certificate on that Edge Services Gateway. So I can actually generate a private certificate right on the Edge Services Gateway without doing anything. Or I can generate a CSR if I'm going to have, either through my domain controller, or if I'm going to go out to, GoDaddy or somebody like that to generate an actual public certificate. Obviously, depending on your use case is going to what kind of certificate you're going to use there. But either way, I need to get a certificate on there that I can use for that Edge Services Gateway or load balancer to identify itself. And once I've done that, it's a pretty simple way that I move forward in just setting, when I create my virtual server, obviously I'm going to create that as an HTTPS, or virtual server. And then when I create my server pool, I can just do that as standard HTTP. So, what I end up with at the end is that, the communications between the servers and the pool, obviously, and the load balancer are plain old HTTP, unencrypted on, whatever port 80 or whatever port I want to use there. But that traffic is set out in the world. I've actually got that TLS encrypted session between my end user clients and the load balancer itself. So that traffic is protected at least through the outside world until it gets into the data center, potentially even then back to the servers behind there. So a few different ways that I can do this, but at the end of the day here is that from a security standpoint, we want to extend that ability to encrypt traffic out to the internet to all of the applications in the data center. And the load balancer is the logical place to do that since we're already creating sessions effectively on either side of it. Now we get into the application rules. So when you create application rules, I'm just going to high level before we get into the specific example. We can do this so there's a separate section in the Edge Services Gateway when you're configuring this to define application rules, and you can do multiple different things at the same time to different virtual servers. I won't even try to go into all of the different things that we can do here with application rules. The security examples here are just kind of scratching the surface. But we can also use these to do any kind of other manipulations that we want to do as around like content switching or rip and replace of stuff that we find in the HTTP headers, that kind of stuff. But in this example, what we're using the application rule here for is to do server masking, preventing that reconnaissance attack that not really an attack per se, but reconnaissance leading up to an attack. So the wire captures, or the Wireshark captures that I've got in here, since I don't know that everybody in the room can read it, but basically what we're seeing here is that when this server responds to an HTTP request, one of the things that I find in that HTTP header is this server field. And you'll notice that it's telling my client, a lot about my environment just out of the box. So in this case, I can tell just by looking at this HTTP response that I'm running Nginx 1.3 as my web server, and that I'm using an Ubuntu OS on here. So you can probably pretty logically, jump to the conclusion that I, as an attacker, would find this information pretty valuable if I'm looking for what exploits are available on a specific version of web server that you're using. I don't want to be advertising to the world what I'm running on the inside. So what we've done here, you can see over on the left where I created the application rule where I'm just using regex values to identify what I want to take out and replace. So really all I did was I created this one rule on the top to say that take that server field out. So I'm just deleting that server field from the HTTP header on the response. And I'm replacing it with super secret as the server type in there. So at the end of the day, what we see then on the packet capture on the other side is that this server field has been replaced. So I'm no longer telling you what web server and what version I'm running and what OS I'm running it on. It just says super secret. I don't have to put anything in there. I can just leave it blank, which might be asking for trouble out in the real world. But at the end of the day, I'm able to do this one simple thing to mask whatever I'm running behind there. So when we talk about best practices around any load balancer that I'm exposing to the real world, this is going to be one of them, just to provide that obfuscation for your environment. Similarly, and this one, I only used PowerShell in this example because I was running it off of a Windows machine. But one of the things that we've seen across some attacks in environments is that attackers, they're not browsing to websites they're attacking with Chrome or Fox. They're using curl or in this case obviously it was PowerShell. And one of the things that we see in HTTP requests is this user agent telling us what browser it is. So in this case, I was running a machine running PowerShell, and when somebody browses to my site with Safari or Firefox or whatever, obviously I want to serve up content to them. That's my end users, right? But when somebody starts trying to run a script against my website with PowerShell or curl or some of these other user agents, I want to shut that down. So in this case, I just said, look for that user agent in that header section, and if it's Windows PowerShell, reject the connection. So just shut it down at a level so that I can't connect to there. That's not the only action I can take. So for example, I could say that if you're using a mobile browser, maybe I want to redirect you to my mobile site instead of shutting your site down or session down. I can really take any of these kinds of actions on this. So for anybody that's ever used like HA proxy, it's a similar nomenclature where I'm basically CLs to match a condition, and then I'm taking an action on it based on that. That's why it's so powerful, is that we're pretty flexible in what we can do there. But in this case, obviously, I've just taken and said that I've got stuff that's out there that I can see that I know probably isn't stuff that I want to have on my website, so I'm going to shut that down. A few more examples before I turn it over to Luke. Obviously, these are all application rules that we created as well. So this top one is an example for a web server. So this is basically saying that I want to reject content that isn't HTTP. So basically what we see there, that TCP request content reject, is just saying that I'm going to reject a connection if, and then exclamation TP is not HTTP. So I use this in that example of stuff that gets through my firewall. Obviously, for my web server at a layer 4 firewall level, I want to allow TCP connections on port 80, right? I don't know what's actually in there. Turns out that I can pretty easily telnet to something on port 80 or anything else. So we actually look at layer 7 and make sure that this connection actually includes an HTTP request. And if it doesn't, I'm going to shut it down. The next one down is more of the slow LoRa's brute force attack. So I basically said that if my session rate from a single user is more than 5 requests per second, I'm going to shut that down. Or I can throttle it, what I want to do there. And the last one, this one is arguable as far as whether this should be done on a load balancer or a firewall, but this is basically just blacklisting an IP address. So I'm saying that if I'm creating this ACL called naughty IP, and it's saying that if your source IP address is this IP, then you've matched this, and then I'm saying that if you're a naughty IP, then I'm going to reject that connection as well. So just kind of a sampling. Obviously, this is very security focused, not content switching or protocol manipulation or anything like that, but an example of some of the stuff that we can do with app rules as well. So that said, I'm going to turn it over to Mr. Luke Sipple from Self-Esteem Brands to talk journey to NSX and our load balancing functionality.
All right, thanks, sir. So as Luke alluded to, Self-Esteem Brands is the parent company to Anytime Fitness and Waxing the City franchises. We have about 3,100 locations across 8 countries, so we're definitely a global presence. And we have just over 3 million active key fobs in our system right now, so pretty cool statistics. We're just going to talk a little bit about how we got here. So I joined the company a little over 3 years ago. And at the time, we were in a co-location in Minneapolis, and we have been having a lot of issues. The rack was completely full. Something needed to happen. So my new boss at the time said, "This is not going well. We're in a bad place. Redo it all. Ready to go. How much money you need, just go ahead and do it." So I got to do everything I wanted to my way, which was pretty awesome. Some of the drivers for the project, we went through a bad string of DDoS attacks, and the provider did not really know how to handle them. We were one of their biggest customers at the time, and we were using a managed F5 offering from them, and a couple times we got DDoSed, and they didn't really know what to do with the traffic, so they would null route the public IP on their edge router and take down our services. And one misconfigured it and took down all of our public-facing services for 8 hours until we could come up with a solution to put in front of what they had to offer. Obviously, I mentioned our rack was completely full, so we needed to do something there. We had no control, obviously, over the managed F5. It was all kits, which was very pokey and slow. Didn't like that. Weekend trips to the data center. We wanted to get to a hands-off model where someone else is handling, replacing hard drives on Friday nights or whatever it might be. We also had physical SQL servers, and we wanted to get to, we were 100% virtualized, so that was a driver for this project as well. We wanted to go into a fully OpEx model and wanted something that was scalable. That's really how we landed on NSX to begin with. And of course, enhanced security with microsegmentation. So we currently have 3 NSX clusters running in production, but this is all just kind of focused on our public-facing one. So we started on NSX 6.2 in mid-2015, and what we wound up going with was Rackspace Managed Colo. So we're basing gear, they're running all the hardware, taking care of it all, but we have completely full control of it from ILO on in. And they also have a 100% network uptime guarantee, which is pretty awesome as well. We went full production on 6.2.4 in October of 20, and that would be with microsegmentation in default block mode, and as well as the load balancing, which we're here to talk about today. We're now on NSX 6.3.1 in 2 of our environments, and since I made this slide, our dev environment has been upgraded to 6.3. The compute environment is composed of 93 production VMs, which is actual compute load, not counting any of the NSX stuff. We are using the per application load balancing that Rush alluded to earlier. So for every service, we make a set of load balancers. Our API pool handles an average of 10,000 requests per minute with a peak of 22,000. Our Club Hub, which is a proprietary application that we use for our franchisees, averages more than that, but a little bit less peak. And our SQL cluster handles 40 a day with 158 million transactions today, just to give you guys a clue of our scale. And when we decided to migrate, we were originally going to replicate all of this original VMs over and just kind of make it easy on ourselves. But instead of doing that, we do completely rebuild every VM onto 2012 R2 and then just swing services over on the cut day. So as I mentioned, we are in default block mode, which was a fantastic learning experience when you have a development team, bless them, who documents nothing at all. And VRNI was not even a thing at the time. So we basically did everything through trial and error, one thing at a time. They would give us an estimate of what ports needed to be opened. We would make the changes. Certain things would work and wouldn't work, and we just had to work through everything. It took a very long time. We now do own VRNI to make our lives a little bit easier going forward. And I already mentioned we do per application. Those are all of the load balancers in that environment. And the one I'm going to show you a screenshot on coming up ahead is the one that is CH, the third one from the bottom. So that's a large one, large-sized ESG. Like Luke said, the one are probably the more common one. We like this design because we can make individual DNS entries for each app server, and then actually when we push changes to it, we can still test against it really easily. So everything is still directly accessible, but there's a public NAT and internal DNS all comes through the load balancer for testing or for actual production usage. And one key point that I did miss on this graphic is that we have encapsula outside of the virtual PA to, obviously, because of all the DDoS issues. We're able to do the per application load balancing because of the low overhead of NSX ESGs. So I don't know if you can read the numbers are really small, but there's a traffic average of about 200 megabits per second and 1,100 concurrent connections. And it's only using 700 megahertz of CPU, 540 megabytes of RAM, and 2 gigs of disk space. So that's pretty impressive. And again, that's the large-sized ESG. So since we were such early adopters, we broke stuff a lot and got to learn lots of stuff along the way. One of the most difficult ones to figure out was a performance bug on the VMX Net3 NIC driver. This was when we were field state, and we were asking our development team to start testing the performance of their apps, and the SQL performance was putrid, and no one could figure out why. And we opened lots of cases with VMware, and it took a really long time, and we finally figured out that there's a bug, and if you manually go edit the ring buffers and some of the offload settings, performance came back 100%, and it worked fabulous. VMware worked diligently to get this resolved in a hotfix, which was awesome, and then the next full release of EXXi just included that in it. We were one of the first couple customers to come across the 6.2.3 global address set issue for the distributed firewall. This was the version that they had to pull down. They released a hotfix for the few people that had already downloaded and installed it, and then they came forward to resolve all these issues. Basically, anytime you would make a change in the DFW rule set, there were just massive chunks of traffic would drop off. And the root cause of it was vMotion. So if you had an environment that had DRS running on it, that just happens. So it just created the problem by itself. We also have run into an issue with the ESGs in HA mode going into like a split brain type of thing. So on a few occasions we ran into this where services, and the quick fix to get everything up was just to reboot the active node, let it fail over gracefully, and everything was happy after that. Since then, VMware now recommends setting up a dedicated HA heartbeat link between your two ESGs, which has been helpful for sure in a while now. And lastly, to note, we've run into quite a few issues with ARP where VMs will just drop off, and it will be, so if you have, let's say, 2 or 3 VMs attached to a logical switch on a specific hypervisor, all those will just drop off the face of the earth. And if you go disconnect and reconnect the NIC, virtually of course, it will come back up, it'll re-ARP and figure everything out. So VMware has been helpful in helping us troubleshoot it, but we have not root caused that one. They just say to and it actually works, and it's just good until we have to upgrade again. There's a session Thursday at noon called Advanced VMware NSX Demystifying the VTEP, MAC, and ARP tables. So I'm definitely going to go check that one out. If anyone else, I would recommend that as well. Because it's handled quite a bit differently than in a traditional physical network. So Luke and Rush have alluded to that NSX has a nice API available to it. One of the, I guess, maturity complaints that we would have about NSX is just the role-based access control is kind of weak or lacking, especially if you want to be able to give the development team access to only their group of ESGs. So what we did was we gave our DevOps guy, Jacob, he's in the room back there, access to API, and he wrote up this nice little web page and can pull up statuses and put these on dashboards. It's all through the API. It's just a quick view so that you don't have to give people full login access into your. Another thing that we're looking to do is going to either green, blue, or rolling deployments, which we will do through API calls. So we'll be able to pull out certain members from the pool, upgrade them, test them, and then through API calls with the deployment processes. We're almost out of time here, so just in summary, we were very early adopters to all of this, and we happily accepted the risk, and we learned a ton along the way. NSX 6.3 has been extremely stable for all the work that VMware has put into the product. Our Rackspace public-facing data center is at 100% uptime so far this year. That's measured, we use Pingdom, and we measure all the way into just a small little Linux VM, so it has to go through all of the NSX path along the way. And if you don't have any outlandish layer 7 rule needs, I would definitely recommend NSX load balancing because it'll probably take care of all your needs. So I think we're going back to Luke to bring it on home.
Yes, sir. Thank you, Luke. So we'll obviously have him still here for Q&A once we get through the... for those that either don't have NSX in your environment or you haven't played with this yet, there's a few different resources and ways that you can get more experience on that. So obviously there are lots of NSX sessions here at VMworld specific to load balancing. One of our technical project managers or product managers, Dimitri, is going to have a session at 30 called the, I can't remember the name of the session off my head. It's just search for elastic load balancing or elastic NSX. Auto-scaling with the load balancer, yeah. So that's one of the topics that he covers. He does a deeper dive on some of this stuff. So fight through the hangover, get up at 8:30 on Wednesday and attend that session as well if you want to learn more. Also, the vMug Advantage now also includes NSX licensing for those that haven't heard. So you're able to get licenses there to play with. So with that said, we're going to open it up for Q&A. If we could have folks that have questions save us from having to repeat them back to everybody else. Outside of that, thank you guys for attending. But we'll open it up to Q&A. One at a time, fellas.
We must have done a really good job.
So I'll try and stump these guys. So does the NSX load balancer support elliptic curve Diffie-Hellman key exchange?
It sure does. So that's one of the things that we can actually determine on the application profile is we can choose from the different ciphers. So under the covers, we're utilizing OpenSSH, so any of the ciphers that can be selected off of there. So one of the enhancements that we made in the version 6.3 update was the ability to not just set a specific cipher per se, but we can actually choose a list now of specific ciphers that we want to be able to support, which has been nice when we get some of these vulnerabilities around like Oracle padding and that kind of stuff that then we're able to selectively choose just specific ciphers that will allow us to weed out the ones that we don't want to have supported in our environment. And again, because of that abstraction point of the load balancer without doing anything on the server behind there as well.
You guys can come up. All right, last one. What is the RFC number for HTTP 1.1?
Probably 7. I don't know.
2616. I don't know that I looked it up.
Okay.
So for the customer story, our issue worries me that that's unresolved. What replication mode are you in? Do you recall? Is it unicast, hybrid, multicast?
We're in the hybrid mode.
Hybrid, okay.
Yep.
And is that because you're an early adopter or any particular reason you're not in unicast mode, I guess? Data, right?
Yeah, yep. I think so the greenfield environment that we had rolled out, we did with the help of pro services. And that was just what was recommended at the time.
Okay.
Again, that was a couple years ago,
So you say you're in hybrid mode, right?
Yes.
So then you must be running some multicast. Do you manage those, or does Rackspace? Do you trust the multicast configuration of those?
That's a really good question. No, they're Rackspace managed.
Okay.
But yeah, that brings up a good point though, because that's the only environment that we've had that problem in, not in any of the other ones. So.
Again, and see the tables, right? The
Yeah.
ARP tables, MAC tables.
Right.
Are they gone from there too? Your
On the
ARPs?
NSX
Yeah.
parts, yeah, they are.
Huh.
Yep.
Okay.
About to get the hook here, so we'll be hanging out for a little bit if you have any more questions, but other than that, thanks again.